So, hi, I am Elgin Bertranolo. So, in this presentation, our topic is all about insertion sort. So, before anything else, we will try to define what is insertion sort. So, what is insertion sort? Insertion sort is the sorting mechanism where the sorted list is built having one item at a time. The list elements are compared with each other sequentially and then arranged simultaneously in some particular order. The analogy can be understood from the style we arrange a deck of cards. This sort works on the principle of inserting an element at a particular position. That is why it is called insertion sort. So for us to be able to understand what exactly is insertion sort, how is it really works, um, we will go to its algorithms. So here is the steps on how the insertion sort works. So let us consider the following list. So we have 5, 4, 7, 9, and 6. So in the insertion sort, we have two types of sublist. Um, the sorted sublist and the unsorted sublist. So the sorted sublists have the length of 1. So in here we have 5. So this is our length of 1. And all the rest of the items will go on to the unsorted sublist. So this is our unsorted sublist. So now we will begin the algorithms how insertion sort works. So let's go. So first, um, we will take the number 4. We will take this number 4 into there. This. Then we'll compare which number is the lesser one. So is number 4 less than number 5? So yes, so it means that we will switch these two. So that's it, 4 and 5. So after switching these two, I will try to compare next the number 7. Is number 7 less than number 5? Number 7 is greater than number 5, so number 7 will be stay there as well as number 5 because number 5 is already lesser than 7. And then the next step, we will take number 9 next. So is number 9 lesser than number 7? So false. It still stay put there as well as number 7 because it is already inserted 5, 7, and 9. So the next step will be we'll take number 6 and compare it to number 9. So is 6 lesser than number 9? So yes, since number 6 is lesser than number 9, we'll switch these two. So it is already switched. It's switched. And then the next step, I will compare number 6 to the left. So is number 6 is lesser than number 7. So it is true. So we'll switch these two, and that's it. So after that, we'll um, compare number 6 to the left. So is number 6 lesser than number 5? So it is false. So number 6 will be in that place. So that's how it works. So this is our sorted list now. We have 4, 5, 6, 7, and 9. So this is our pseudocode in insertion sort. This is it. The next, um, we have the Python implementations of insertion sort. So we will try to code this one for us to understand its logic of this syntax. So for now, we will go to Python, and then let's create a function. Put this def, then the name of the function. We will name it um, insert insertion sort. Let's take this sequence. Let's call it list, and then next line, we will name this um, indexing length. Indexing length is equals to range 1 comma len list and then list. Um, Remembering in the beginning of my presentation that the first item on our sorted list is already in the sorted, so our range will start at number 1. And the next, I will create a for loop. So for I in indexing length, we will use for loops to because we want to sort those values, and then I will put value to sort equals list I I um we will go one by one in the indexing length and taking the sort so we can sort them. So we'll take this one by one. So we put this, and then we'll create a while loop. Um, while list minus one is uh, is greater than the value to sort, and I is greater than 0. The meaning of this is that if um, the item to the left or the number to the left is larger than the item to the right, then we need to switch those two. So this is why if the left number is greater than the right number, then I will switch those two. And for this, we have to say this statement here because Python allows negative indexing. So we will always start to 0, and then so we will continue the comparisons down the list, and we can do that by saying I is equal to I minus 1. And then after that, um, I will create we will return the list. So we will type we will type return list, and then let's put this put here print um, sorted list is um, next line we'll put print and then the insertion sort, then this the bracket. So we'll put any number in this line. So I will put numbers 9, um, number 9, number 7, number 6, number 2, number 8, number 5, number 1, number 9, number 6. So that's it. This is um our code. So we will run this. Oh, why is this happening? With this. Ah, I forgot the line here. So list I forget the switching part. List I comma list um I minus one because I just switches two components, so list I minus one comma I. So that's right. So here is our sorted list. So we are successfully completed the sorting, the selection insertion sort. So go back. So insertion sort algorithm. This algorithm performs at the same complexity as the bubble sort and the selection sort method. However, this one can be a little bit faster most of the time. So that's why people tends to prefer this one over those two. And that's it. Thank you so much for listening and for watching. Abu.